My name is Hadi Farhangi on Basics of Statistics, Variables, and Distributions. Topics of this video are first introduction, Bernoulli distribution, binomial distribution, Poisson distribution, normal distribution, and finally T-student distribution. First topic, introduction. We saw that a statistical variable is a variable that takes different values non-deterministically. We also saw that histogram is a frequency chart for a statistical variable. It shows the frequency of observations for all ranges of the variable. Here, an example of histogram, variable versus frequencies are considered in the histogram. Distributions. If one increases the number of bins and connects the top of the resulting histogram for relative frequencies, a distribution will appear. Here's an example of distribution that the tops are histogram, that the tops are connected, and that green light is a distribution. A distribution can be symmetrical, or it can be skewed to right, or can be skewed to the left. Next topic, Bernoulli distribution. Bernoulli distribution is a distribution of a statistical variable that takes value of 1 with the probability p and the value of 0 with probability 1 minus p. Here's the notation: x is equal to 1 with probability p, 0 with probability 1 minus p. Example, tossing a coin is a case of a Bernoulli variable in which probability of getting a tail is 0.5 and not getting a tail is 1 minus 0.5, which is equal to 0.5. Next topic, binomial distribution. Binomial distribution is the distribution of a process that repeats a simple Bernoulli process n times or n trials. In another word, y has a binomial distribution if y is equal to x1 plus x2 all the way plus to xn. Because every xi here can be either 0 or 1, variable y can be between 0 and n. So y can be 0, 1, all the way to n. If y is a binomial variable with n trials and success rate of p, then it is shown with y is binomial n and p. Probability of k success in binomial distribution is probability of y equal to k is combination of n and k times p power k times 1 minus p power n minus k. The mean and variance of binomial variable can be calculated as follows. Mu or mean is n times p, sigma square or variance is np times 1 minus p. Here's an example. Assume one tosses a coin 3 times. What type of variable represents this experiment? B, calling the variable y, what is the maximum value of y? C, what is the probability of y equal to 0? D, what is the probability of y equal to 2? Answer. A coin toss is a Bernoulli variable, and the summation of 3 Bernoulli variables gives a binomial variable. So it is a binomial variable. B, max of y is n equal to 3. For parts C and D, it is known that n is equal to 3 and p is 0.5. Hence, probability of y equal to 0 is, using the formula, combination of 3 and 0, half power 0, 1 minus half power 3 minus 0, which is 1 times half power 3, which is equal to 0.125. Part D, probability of y is equal to 2 following the formula is combination of 3, 2, half power 2, 1 minus half power 3 minus 2. Combination of 3 and 2 is 3, and 1 minus half power 3 minus 2 is half power 1. So we have 3 times half power 2 times half power 1. If you do the calculation, it is 0.375. Here's another example. The probability of a customer in a coffee shop ordering iced tea is 10%. In one day, 10 customers enter the coffee shop. A, what is the probability that none of them order iced tea? What is the probability that at least one of them orders iced tea? 3, what is the mean and variance of variable? Okay, now pause the video, use binomial distribution, and answer this question. Here's the answer. For part A, probability of y equal to 0, none of them 0, is 0.3487. Probability of y greater than equal to 1 is 0.6513. C, mu is n times p, which is 10 times 0.1, which is equal to 1. Variance is equal mp times 1 minus p, which is 10 times 0.1, 1 minus 0.1, which is 0.9 at the end. Next topic, Poisson distribution. Poisson distribution is similar to the binomial distribution in which it shows success and failure. However, the success of a Poisson variable is measured as the rate during an interval. Here's an example. The number of phone calls received in a call center between 11 a.m. and 12 p.m. follows the Poisson distribution if the rate for every day remains the same. Definition. Poisson variable shows the number of events occurring in a fixed interval if one knows the success rate. The interval can be time, space, volume, and the rate of success should remain constant in the interval. Assume x is a Poisson variable with success rate of lambda. One Poisson distribution is shown as P of lambda. The probability of k success can be calculated as probability of x equal to k is lambda power k e minus lambda divided by k factorial. If x is a Poisson variable, then lambda is between 0 and 1. That letter is a Greek letter lambda. And x can be 0, 1, 2, 3, all the way to infinity. And the mean and variance of Poisson distribution is lambda. Here's an example. Assume a car wash accepts cars at a constant rate of 2 cars per hour. For a period between 1 p.m. and 2 p.m., calculate the probability of having 0 car, 1 car, 2 cars, and 3 cars. Here's the answer. The rate is known to be lambda equal to 2. The probabilities are calculated by the formula. Probability of x equal to k is lambda k, e power minus lambda divided by k factorial. Probability of 0 car is when k equal to 0 in the formula, which will be lambda power 0 e minus lambda divided by 0 factorial. Substituting lambda equal to 2, it will be 2 power 0 e power minus 2 divided by 0 factorial, which is 1. So 1 e minus 2 divided by 1, which is e minus 2, which is equal to 0.135. Probability of 1 car is when k is equal to 1, so lambda power 1 e minus lambda divided by 1 factorial. Substituting lambda 2 in this equation will be 2 power 1 e power minus 2 divided by 1 factorial. which will be 2e minus 2 divided by 1, which is 2 times e power minus 2. If you do the calculation, it will be 0.2716. Probability of two cars when k is now equal to 2, it will be lambda power 2 e power minus lambda divided by 2 factorial. Substituting lambda equal to 2 will be 2 power 2 e power minus 2 divided by 2 factorial, which will eventually be 2 times e power minus 2, which shown to be 0.2716. Now probability of three cars. So here k is equal to 3, substituting that in the formula will be lambda power t, e power minus lambda divided by 3 factorial, which is 2 power 3 e power minus 2 divided by 3 factorial. 2 power 3 is 8, 3 factorial is 6. If you put the calculation, it will be 8 times e power minus 2 divided by 6, which is 0.1804. Next topic, normal distribution. A normal variable is the most famous statistical variable. Many variables in nature follow a normal distribution. The range of this variable is all the real numbers. The variable is continuous and probability of it having a certain value is 0. One only calculates the probability of normal variable being in a particular range. If X has a normal distribution with the mean mu and variance sigma square, it is shown with X is normal with mu and sigma square. The figure shows normal distribution and shades the area that the probability formula returns. Here's the shade and shaded area in the normal distribution. As you can see, it's a bell shape, and the probability of being less than A is that shaded area, and you use this formula for the calculation. We are not going to get to the formula. We are going to use software for the calculations. A standard normal variable is a special kind of variable with the mean mu equal to 0 and variance sigma square equal to 1. In another word, z is normal with 0 and 1. Note that if x is normal with the mu and sigma square, then x minus mu divided by sigma is a standard normal with 0 and 1. This property of the normal distribution is very important and has many usages in the confidence interval and hypothesis testing. One important notation, Z alpha. Based on the figure below, Z alpha is a value of the variable standard normal that probability of Z being less than Z alpha will be equal to alpha. So alpha is the probability, Z alpha is a value of the Again, note that alpha is the area below the distribution up to the Z alpha. More on normal distribution, the symmetric property of normal distribution. As you can see in this figure, we have x and minus x. Probability of z greater than x is the same as probability of z less than equal to minus x. One can use software to calculate alpha if Z alpha is known, and calculate Z alpha if alpha is known. Calculating alpha if Z alpha is known using Google Sheets. So assume Z alpha is X, probability of Z less than equal X can be calculated using the function norm.dist, and inside parentheses you put X, comma, 0, comma, 1, comma, 1. Only X is changing. Calculating Z alpha, if alpha is known, using Google Sheets, is the function norm.inverse. And you put alpha, comma, 0, comma, 1 inside parentheses. Here's the example. What is the probability of Z less than equal to minus 1? Here's the answer. Probability of Z less than equal to minus 1 is norm.dist minus 1, comma, 0, comma, 1, comma, 1, which is 0.158. Here's another example. What is the value of Z if alpha is 0.8? Here's the answer. Z alpha is norm.inv, inside parentheses, alpha, comma, 0, comma, 1, which is alpha is 0.8. If you put it in the formula, will be 0.8416. Here's another example. Calculate following cases. A, probability of Z greater than 2. B, value of X when probability of Z being greater than X is 0.4. Here's the answer. For part A, probability of Z greater than 2 is equal to probability of Z less than minus 2 based on the property we have, which is norm.dist X 0, 1, 1, substituting X minus 2 will be norm.dist minus 2, comma, 0, comma, 1, which is, comma, 1, which is 0.0228. For part B, probability of Z greater than X is 0.4. Probability of Z minus, less than minus X is also 0.4 based on the property. So minus X is the normal dot inverse 0.401, which is minus 0.2533. So minus X is minus 0.2533. So X is 0.2533. Here's another example. Assume Y is a normal variable with the mean of 10, mu is equal to 10, and a standard deviation of 2, sigma is equal to 2. A, calculate Z value for Y equal to 20. B, calculate probability of Y greater than 11. C, calculate probability of Y less than 6. D, Y such that alpha is 0.95. The answer. For part A, Z is equal to Y minus mu divided by sigma based on the equation we saw before. Y is 20, mu is 10, sigma is 2. So substituting all those values will be 10 divided by 2 equal to 5. Part B, probability of Y greater than 11 is equal to probability of its standard normal greater than 11 minus 10 divided by 2, which is probability of Z greater than 0.5. which is based on symmetric property, probability of Z less than minus 0.5. So if you use norm.dist minus 0.5, comma, 0, comma, 1, comma, 1 in Google Sheet, it will return 0.3085. For part C, probability of Y greater than 6 will be probability of its standard normal less than 6 minus 10 divided by 2, which is probability of Z less than minus 2. In Google Sheet, if you write equal norm.dist minus 2, comma, 0, comma, 1, comma, 1, it will return 0.2275. So norm.dist inside parentheses minus 2, comma 0, comma 1, comma 1 is what you write inside Google Sheets. And once you hit enter, it will return the probability. For part D, Z alpha is norm.inverse inside parentheses alpha point 0.1, and if you write in Google Sheet norm.inverse is zero point 0.9 inside parentheses 0.95 comma 0 comma 1, it will be 1.65. So Z value for 0.95 is 1.65. Using the formula that we saw before and reordering, Y will be mu plus sigma times Z. Mu is 10, sigma is 2, Z is 1.65. If you substitute, do the calculation, Y will be equal to 13.3. Next topic, T-student distribution. T-student variable or T variable is a continuous variable similar to a standard normal. It has the mean of 0 but a different variance. It is shorter than a standard normal with thicker tails. Here's a figure that shows T variable and Z variable side by side. Z variable is shown in red, which is taller, and T variable it is shown in green, which is shorter with thicker tails. If X has a T distribution with the degree of freedom nu equal to n minus 1, one can show it by X is T nu. One important notation is T alpha. Based on the figure, probability of T less than T alpha is equal to alpha. So everything below the area, below the T variable and less than T alpha will be equal to alpha. Symmetric property of the T distribution is that probability of T greater than X the same as probability of T less than minus X. This is similar to a standard normal. One can use software to calculate alpha if T alpha is known and calculate T alpha if alpha is known. Calculating alpha if T alpha is known using Google Sheets. Alpha is equal to probability of T less than T alpha, and nu is equal to T dot dist inside parentheses X comma nu comma 1. Calculating T alpha if alpha is known using Google Sheets, T alpha is equal to T dot inv inside parentheses alpha and nu. Example, what is the probability of T less than equal to 2 if nu is equal to 7? The answer, probability of T less than equal to minus 2 with the nu equal to 7 is T dot dist X comma V comma 1, putting X and V over there, T dot dist minus 2 comma 7 comma 1, which is 0.0428. Another example, what is the value of T if alpha is 0.8 and V is equal to 14? Answer, T is equal to T dot inverse alpha and nu, which is equal to T dot inv inside parentheses 0.8 comma 14, which is 0.8681. Here's another example. Calculate following cases. A, probability of T greater than 3 and nu is equal to 16. B, value of X where probability of T being greater than X is 0.1 and V, degree of freedom, is 10. A, probability of T greater than 3 with degree of freedom 16 is equal to probability of T less than minus 3 and V equals 16, which is equal to T dot dist minus 3 comma 16 and 1, which is 0.0042. B, probability of T greater than X with a degree of freedom of 10 is equal to probability of T less than minus x equal, and degree of freedom of 10 equal to 0.1, which means minus x is t dot inverse 0.1 and 10, which is minus 1.3722, which means x is equal to 1.3722.